Hello Sunbeamers, I hope you all are fine. Today we are going to start new chapter of chemistry and the most important chapter, that is a basic chapter in chemistry, that is elements, compounds and mixtures. In the class 6, I know you have introduction to chemistry, but that is not so important. So we are skipping that. We are beginning our chemistry with elements, compounds and mixtures. So matter, what is matter? Anything that have mass. Anything that have mass is known as your matter. Matter is divided into two parts, non-living and living matter. Non-living means your living matter you will read in biology, which we have already read, classification of plants and animals. And further in higher classes, you will also read animal physiology and plant physiology, different biological functions of animals and different biological functions in plants. In chemistry, basically, we will focus on this non-living matter. And this non-living matter is again divided into two parts, two groups, homogeneous and heterogeneous. Homogeneous matter is again divided into three groups or three categories, elements, compounds, and mixtures. And these elements are divided into metals, non-metals, and metalloids. And in heterogeneous, we have only mixtures. So what is matter? I have told you, made up of atoms that can broadly grouped into solid, liquid, and gases. Matters are made up of teeny particles called as atoms. Small atoms make your matter. Okay. So before starting your elements, compounds, and mixtures, we have to learn about atoms and molecules. What are atoms? What are molecules? What is atom? Tiniest and smallest part of an element that can exist and still have the property of an element is known as atom. Smallest part, suppose I am considering iron. That iron you are seeing is made up of small teeny particles called as iron atoms. And that iron atoms have the property of iron. Because iron is an element. And that iron element is made up of teeny small part atom. And that atom also has the property what is there in iron element. Because that is an iron atom. वो आयरन एलिमेंट में जो जो टीनी पार्टिकल्स होंगे वो पार्टिकल में भी आयरन एलिमेंट का प्रॉपर्टी होगा और उसको बोलते हैं हमें एटम. टीनिएस्ट एंड स्मॉलेस्ट पार्टिकल, smallest part of an element that can exist and still have the properties of the element. How was the word atom used? It was first used by Democritus from the word atomus, which is a Greek word which means indivisible. And J.J. Thomson put the idea that atoms again can be split into subatomic particles. एक एटम में भी, ये देखो ये एक एटम है, ये एटम है, छोटा सा एटम है, टिनी पार्ट, उस एटम में भी छोटे छोटे पार्टिकल्स होते हैं. क्या? Subatomic particles. They are called subatomic particles. What are the subatomic particles? Electron, neutron, and proton. These three are the subatomic particles. And you see here a figure of the atom. An atom looks like this. Okay, it has a nucleus and orbits. These orbits are imaginary where electrons revolve, electrons rotate करते हैं. So हम थोड़ा आगे पढ़ेंगे. J.J. Thomson, who named electron? Electron was named by or discovered by J.J. Thomson. ये नाम याद रखना पड़ेगा, J.J. Thomson. Okay. And what is that electron? स्मॉलर पार्टिकल्स दैट हैज नेगेटिव चार्ज. हम लोग फिजिक्स में चार्ज के बारे में पढ़े थे, पॉजिटिव चार्ज एंड नेगेटिव चार्ज. एवरी बॉडी, एवरी मैटर इज मेड अप ऑफ पॉजिटिव चार्ज एंड नेगेटिव. तो वो नेगेटिव चार्ज कैरी करने वाले पार्टिकल्स को हम लोग बोलते हैं इलेक्ट्रॉन्स. वी से देम एज इलेक्ट्रॉन्स. ओके. एंड द और एक बॉडी को अगर न्यूट्रल होना है तो उसमें पॉजिटिव चार्ज भी रहना पड़ेगा, बिकॉज without presence of positive charge that body will not be called as neutral, and every atom is electrically neutral. So how it will be electrically neutral? By presence of positive charge, and that positive charge is called proton. See, these white structures you are able to see, that is a proton. Okay. And here in the center of your atom you have the nucleus. Inside the nucleus you are having two particles, protons. These white parts are protons, and these black parts are called neutrons. Neutrons means neutral, protons means positive charge. Positive. Neutrons means zero charge or no charge, neutral particles. And number of protons are always equal to the number of electrons in an atom. In a neutral atom, to make the atom electrically neutral, number of protons are equal to the number of electrons. And why the atom is electrically neutral? Neutral means zero net charge. Because protons are positive charge. Suppose carbon atom. Carbon atom has 6 proton, it has 6 neutron, and it has 6 electron. Number of proton Np is equal to the number of electron Ne. See, 6, 6. So is carbon atom neutral? Yes or no? Yes. So carbon atom is electrically neutral. You have to write in exam, electrically neutral. Atom is electrically neutral. And if you see the structure of the atom, some students must remember about the solar system. Some student must be thinking about the solar system. In the center, you have the sun and other planets are rotating. So this atom structure is based on the solar system structure. And this center located is the nucleus. And electrons are the planets revolving around the center. Okay. Now you see here. Terms to note. The terms to note, the second point is atoms join up to form the molecules. And what are molecules? Two atoms combine, two or more atoms combine to form a molecule. A little bit larger than the atom. Smallest particle of an element or compound that can stand on its own. Because it is a combination of atoms, so it can stand on its own. Suppose your hydrogen H2, two hydrogen atom combine to form H2 molecule, and the gas you are seeing, hydrogen gas, is a molecule H2. Okay. And this molecule make compounds. And a compound can have one type of atom or different types of atoms, like H2O, water. There are two types of atoms here, hydrogen atom, oxygen atom. So now you will be thinking, what is this H? What is this Cl? What is this O? These are the chemical symbols that we denote to the elements for writing the chemical formula. Okay. Here something is written. Elements, atoms of most elements are not stable. Why? Because a single atom cannot exist freely. One atom cannot exist independently. So in order to stable, they join with each other to form molecules. And the molecule is stable. See, hydrogen atom cannot exist independently. So it joined with chlorine and formed the HCl molecule. And what is molecule? Definition is here. Smallest particle of an element or compound that can stand on its own. It can exist independently, molecules. Atom cannot exist independently. They are not stable independent. They join with each other to form molecules. Now your symbols. You have to remember your some symbols because at this stage, valency and all are not given in your course. Just you see here, iron Fe. These are the symbols that represents the elements. Zinc is Zn, copper is Cu. Now you will say zinc Zn, you can see these letters from zinc, Z and N, but iron, how it is Fe? See, some elements names are derived from the Latin names. In Latin, iron is called as ferrum. And from the ferrum, we derived the name Fe. Copper is called cuprum. So from cuprum, we derived copper, Cu. Magnesium is Mg. Lead is Pb. Calcium is Ca. Oxygen is O. And carbon is C. This one you have to remember. Lead YPB, plumbum. Okay. Now elements. Elements. What are elements? Elements are pure substance that are made up of one kind of atom. Pure substance means substances that are made up of one kind of material or thing. So one element, suppose I am telling element iron, Fe. This Fe is made up of Fe atoms. Oxygen made up of oxygen atoms. Copper made up of copper atoms. Sodium is denoted as Na. Sodium, Na, natrium. Sodium is called as natrium in Latin. So sodium is called as Na. So all atoms of an element contains the same number of protons and electrons. Yes. Number of protons is equal to number of electrons. And atoms of different elements differ from one another with respect to the number of protons, neutrons, and electrons, which are called as subatomic particles. Suppose I will consider two elements here. Sodium, Na, sodium, and magnesium, Mg. Or for your easiness, carbon, nitrogen, N. Nitrogen is carbon. How many electron? 6 electron. How many proton? 6 proton. How many neutron? 6. In nitrogen, there are not 6 electron, 6 proton, 6 neutron. There are 7 proton, 7 electron, and 7 neutron. So one element, number of protons, electrons, and neutrons differs with other element. Okay. Sodium and magnesium. Sodium and magnesium has 11 proton, 11 electron. Magnesium has 12 proton, 12 electron. So they are different. Okay. Good. Yes. In the universe, hydrogen and helium are the commonest element. Most found element in the universe are hydrogen and helium. How many percent? 98%. But in Earth crust, oxygen is the most abundant element. And second most is your silicon. Together they form 75% or 3/4 of the crust. 3/4 means 75%. 1/4 is 25. So what is the most abundant element in universe? Hydrogen and helium. In earth crust, oxygen. Second is silicon. In human body, carbon, hydrogen, oxygen are the most common element. Why? Because they form the cell constituent. See, human body is made up of cells. So mostly in the human body, you will find carbon, hydrogen, and oxygen. Also, copper, silver, gold, and platinum are found in low states. Okay. So far, how many elements are known? 118. How many elements? 100. We know so far 118 elements. And out of that, 89 elements are natural occurring nature, and 20 are prepared artificially. लैब में प्रिपेयर किया गया एलिमेंट को artificially. So 89 are your naturally occurring and 20 are artificial element. Only a few elements exist freely in the nature. Most are so reactive that they join with atoms of other elements and exist in compounds. देखो फ्री एलिमेंट बहुत कम मिलेगा क्योंकि एटम इज नॉट स्टेबल. So it has a tendency to combine with other atoms and be stable as molecule. Elements are found in 3 states. How many states matter have? 3 states: solid, liquid, and gas. Okay. So under normal conditions, we have 2 liquid elements, bromine and mercury, and 11 gaseous elements, carbon, nitrogen, oxygen, so on. See, gaseous element, here it is given. Carbon, nitrogen, hydrogen, helium, chlorine, fluorine, neon, argon, radon, krypton, xenon. And all other are solid elements. On earth crust, oxygen is the abundant element, and in atmosphere, nitrogen is the abundant, and next is oxygen in atmosphere, air. So elements are divided into metals, non-metals, and metalloids. Okay. So solid example, liquid example, mercury and bromine, and gas, oxygen, nitrogen, hydrogen, helium, lithium, beryllium, helium, chlorine, fluorine, neon, argon, radon, xenon, krypton. See, symbols are given. You have to remember potassium K, calcium Ca, sulfur S, carbon C, magnesium Mg, lead Pb, tin is Sn, stannum Sn, oxygen O, nitrogen N, hydrogen H, helium He, chlorine Cl. First letter is always capital, second is small. Fluorine F, neon Ne, argon Ar, radon Rn. Xenon is Zxe, and krypton is Kr. See how element are present. 46% oxygen, 26% silicon, 7% aluminum, 4% iron. Like that we are having your elements in the earth crust. Now metals and non-metals. Difference, very easy. In your home, your mother is cooking in metals, steel utensils. So you can easily find out the properties of metals. Generally, metal is solid. Exceptional is mercury, which is a liquid metal. See, you put the light on your steel utensil, you will see they have a shiny surface. They are malleable and ductile. What is malleable and what is ductile? I will tell you. Let me read all the points first. Then I will tell you what is malleability and what is ductility. These are the two properties of your metals. Malleability and ductility. So next point is your high melting and boiling point. See, metals have high melting and boiling point. ज़्यादा temperature में वो boil होंगे. Next point is they have a high density. They have a high density. Yes. And they are good conductors of heat and electricity. हमारे जो कॉपर वायर्स होते हैं वो मेटल है ना. Malleability means metals can be hammered or they can be made into thin sheets, and ductility means wires. But with non-metals, they cannot be made into thin sheets or wires. Okay. Iron, copper, lead, aluminum, zinc, mercury, calcium. Some examples of metals. Non-metals. Non-metals exist in normally they exist in solid gases at room temperature, and liquid non-metal is bromine. They are not lustrous. They have a dull surface. Exception is graphite. Graphite is lustrous in nature. Melting point and boiling point are low. Density is also low. And they are not the poor conductors of heat and electricity. Only graphite is an exception. Graphite, two exceptions. Graphite is lustrous and also it is a good conductor of heat and electricity. Other non-metals are not the good conductor. They are the poor conductor of heat and electricity. And also bromine is a liquid non-metal. Others are solid and gases. These are the difference between your metals and non-metals. Now metalloids. Metalloid is a separate group. Metalloids means they have both the property of metal and non-metal. Example your boron, silicon, germanium, arsenic and antimony. You have to remember. Okay, silicon also. Silicon is a bad conductor of electricity at ordinary temperature, but it is a good conductor at when boron is added to it. When we add boron to silicon, it becomes a good conductor. This is your what you say application of semiconductor. We will read in higher classes. Historical note on element. First, simplest element is hydrogen. First element to be formed at universe, hydrogen. Second element formed is helium. First element to become known, iron. Iron was the first element that became known. Okay. Now, compounds and mixtures. We will read in the next class. Okay. Compounds and mixtures. We will read in the next class. Elements and atomic structure. How to draw an atom. We have read. Okay, we will meet in the next class. Till then, thank you. Like and subscribe. Bye bye.